Hi, this is a small talk about the core book by Vector Intelligence, the project I built for software development agencies, small to medium. You can find more about the project in our website and blog. But basically the talk is about how good architectural choices and strategies can help you when building something that requires lots of experimentation, and you don't really know the outcome of every bet you made architecturally. So this choice was that we treat all the data we ingest as a source of truth. So we extract source records from our ingestion channels, and we are backing it up. Then later on we are extracting all sorts of indexes from this data, and of course embeddings for vector search, and we are extracting structured memory items. These structures are categories, and also we are extracting entities and relations. The bet I made is that the graph traversal should aid vector search, because it's a similar of the way of how people think. We are always adding values to the entities in our mind, and we have all sorts of connections between the entities. Part of the issue was choosing a benchmark that data set. This data set looked good at the time because it contains long chains of conversations, sort of similar of what we were ingesting, let's say from Slack or other ingestion channel. We got pretty good benchmarking, 90%. And we worked a bit on retrieval times, to enhance retrieval times, but from the start the graph channel contribution was 0, so actual issue was in the structure of the long level data set. Simply this data set doesn't have it's optimized for long context recall and doesn't have any relational structure that we could exploit with the graph retrieval. What made the impact in our vector search is superside aware re-ranking. So I used the event sourcing design pattern for the idea, and it's like we always keeping the original memory and updating it with the rank. So the fact or the decision can be updated, and all the traces of the decision process can live in the database. We were able to simply disable the graph retrieval because the retrieval was designed in such a way it had 2 lanes, and we just can flip the switch. I guess the point is, in the age of AI, when the development cycles are faster and faster, we should strive to keep the good practices and industry standards and architectural lessons that led us along the way up until now, and try to have a deep understanding of the systems we built. In this concrete example, we had a source of truth which is the original data upon which we can always rebuild from scratch if anything went wrong. And also, once we have a real data from the pilot, we can always test our concept of graph traversal and see the contribution gains. That's it. Bye.